The James Webb Space Telescope has done it again, discovering a galaxy so ancient it's forcing scientists to rethink the rules of cosmic history. This finding could change our understanding of the early universe, but to appreciate its significance, let's rewind. Not to the dawn of time, but to 2022. Up until that year, the most distant galaxy ever observed was GNZ 11, spotted by the Hubble Space Telescope. It was a landmark discovery. Hubble, with its 2.4-meter mirror and exceptional optics, had taken us incredibly deep into space, but there was a limit to how far it could see. Then came the James Webb Space Telescope, equipped with a massive 6.5-meter mirror and finely tuned to the infrared spectrum, exactly the kind of stretched, ancient light that early galaxies emit. Webb didn't just continue Hubble's work, it shattered previous records. In one of Webb's early observation campaigns, astronomers found a galaxy named Jade's GSZ14, which became the most distant confirmed galaxy at the time, with a redshift of 14.32. For context, redshift measures how much the light from a galaxy has been stretched by the expansion of the universe. The higher the redshift, the older the light. Shortly after, another galaxy, MOM-Z14, was identified with a redshift of 14.44, pushing humanity's view even further back in time. What really amazed scientists wasn't just the redshift, but what the galaxy looked like. MOM-Z14 is incredibly compact, just about 500 light-years across, tiny compared to the Milky Way's sprawling 100,000 light-years. Yet it shines with remarkable brightness. Normally, galaxies this early should be faint and difficult to detect, but MOM-Z14 is a stellar nursery on overdrive, producing newborn stars at an extraordinary rate in the universe's first few 100 million years. One feature, or rather one notable absence, makes MOM-Z14 even stranger. It lacks a supermassive black hole. Most galaxies with intense star formation harbor these cosmic giants at their centers. Supermassive black holes are thought to regulate star birth, shape galactic structure, and drive growth, but MOM-Z14 seems to thrive without one. The mysteries deepen. Using JWST spectrograph to study the galaxy's light, astronomers discovered it is unusually rich in nitrogen. This chemical signature resembles what we observe in some of the oldest star clusters orbiting the Milky Way, implying that MOM-Z14 is forming stars in extremely dense environments. This was unexpected. Galaxies this early should be chemically simple, composed mostly of hydrogen and helium. Instead, MOM-Z14 shows that multiple generations of stars had already formed and died, suggesting that galaxy evolution began far earlier than previously believed. This raises a profound question. How many more galaxies like MOM-Z14 are out there? Before Webb, astronomers thought galaxies this ancient would be extremely rare. But now, these ancient, bright galaxies, sometimes referred to as little red dots, are appearing across Webb's surveys more frequently than expected. While MOM-Z14 may currently hold the record for the most distant galaxy, it might not hold it for long, as more discoveries are already on the horizon. The more we observe, the more the universe surprises us, and each new discovery chips away at what we once assumed. If galaxies like MOM-Z14 existed in greater numbers, formed stars faster, and were chemically richer than previously imagined, what else are we missing? Does this galaxy challenge our cosmological models? The answer is clear: yes. Current models of galaxy formation predict that galaxies this early should be rare, slow-growing, and chemically simple. MOM-Z14 defies all of these expectations. It is fast, luminous, and chemically complex, demonstrating that our understanding is incomplete. This remarkable galaxy hints that the early universe may have been far more dynamic and active than we previously imagined. And this is just the beginning. Later in this decade, the Nancy Grace Roman Space Telescope will join Webb in exploring the early universe, surveying much larger swaths of sky with extraordinary resolution. Together, these telescopes could uncover hundreds or even thousands of galaxies similar to MOM-Z14. Each of these galaxies is a time capsule, providing invaluable insight into an era of cosmic history that we are only beginning to comprehend. For now, MOMSI 14 stands as a landmark, a flicker of light from a time when the universe was still finding its footing. Yet the deeper we look into Webb's findings, the more the cosmos seems to defy expectations. Some researchers, pushing the boundaries of conventional thought, have proposed something radical. What if our entire universe exists inside a black hole? This idea arose from a curious observation. Many galaxies appear to rotate in the same direction. By studying the spiral arms, astronomers can determine the spin of these galaxies. In a truly random universe, galaxy rotation should be roughly evenly split between clockwise and counterclockwise. The fact that they are not hints at a profound mystery and has led some to speculate that our universe itself may reside inside a black hole. To grasp this, we need to look at black hole physics. When matter collapses under gravity into a black hole, it forms an event horizon, a boundary beyond which nothing, not even light, can escape. What happens inside remains one of the greatest cosmic mysteries. Black hole cosmology, or Schwarzschild cosmology, proposes that our observable universe could be the interior of a black hole, nested inside a larger parent universe. Consider the Big Bang. According to standard cosmology, the universe began as a singularity, a point of infinite density, very much like the center of a black hole. If our universe is actually inside a black hole, the Big Bang would not have been an explosion into empty space, but rather the moment matter collapsed into a black hole, creating a new universe inside. This concept has even deeper implications. Every black hole in our universe could potentially be a gateway to a baby universe. It might also explain why the fundamental constants of nature appear so precisely tuned for life. Black holes capable of generating stable universes may be more likely to persist and propagate, forming a kind of cosmic natural selection. Scientists believe that this bold idea could potentially explain several long-standing cosmic mysteries. For instance, black holes are known to harbor immense entropy, which corresponds to the staggering amount of information contained within our universe. Another factor that could play a role in this scenario is torsion. In extended versions of general relativity, such as Einstein-Cartan theory, torsion is a property that accounts for the intrinsic spin of particles and can influence the curvature of space-time. Some theories suggest that this twisting effect could generate a repulsive force at extremely high densities, potentially preventing singularities from forming. If this is correct, it might mean that instead of collapsing into an infinitely small point, a black hole could experience a big bounce, where its core rebounds and expands outward, possibly giving rise to a new universe inside. Scientists further propose that the rapid expansion following such a bounce could explain our expanding universe, an event we now refer to as the Big Bang. In this model, the Big Bang would not have been a singular explosion from nothing, but rather a rebirth emerging from the core of a black hole in a larger parent universe. This theory would dramatically reshape our understanding of cosmic origins, implying that the cycle of universes is a continuous, self-replicating process. Another fascinating possibility concerns the large-scale structure of the universe. Some studies suggest that galaxies are not distributed entirely randomly, but may instead show a subtle alignment, a preferred cosmic axis. This phenomenon, known as cosmic anisotropy, challenges the long-held cosmological principle, which assumes the universe is homogeneous and isotropic on the largest scales. If the universe truly has a preferred direction, it could point to unknown physics at play, potentially linked to the way our universe formed inside a black hole, or to the interactions of fundamental forces on the grandest cosmic scales. Adding to the puzzle, the presence of ancient massive galaxies so soon after the Big Bang further challenges our understanding of cosmic evolution. While the theory of a universe inside a black hole is tantalizing, there could also be simpler explanations for some of these unexpected observations. For example, it's possible that earlier measurements, like the rotational speed of the Milky Way, might have been slightly off. Regardless of the explanation, the universe is proving to be far stranger and more complex than we ever imagined. Observations such as uneven galactic rotations are likely to prompt astrophysicists to rethink key aspects of our current models and theories. What do you think about all this? Share your thoughts in the comments below. And as always, don't forget to subscribe to Space Diary because this is your space.